Hi everyone, welcome to my channel Nihal's Lab Notes. In this video, we are going to see Apriori Algorithm. But let's get started with a basic concept. In the previous video, we have already seen an overview about data mining. In this video, we are going to start with basic data types. So we have two basic data types: no dependency-driven data and data focused on dependencies. First of all, let's start with no dependency-driven data. Records of data does not have specified relationships between data elements or attributes. For example, a set of demographic records on individuals containing their age, gender, and postal code. Secondly, data focused on dependencies. Implicit relationships or explicit may exist between data elements. For example, a data set from a social network contains a set of vertices items linked together by a set of edges relationships. For the first type of data not focused on dependencies, we have multidimensional data. For example, we have quantitative data. It's generally numerical, for example, the age. Categorical data. In ordered values, for example, if we have gender, race, or postal code. Second type of this data not focused on dependencies, we have the binary data. It's a special case of categorical data and or quantitative data. For the third type, we have text data. Generally not useful in raw format. Transformations are necessary, for example, back of words. Now let's see another type of data. It's dependency-focused data. We have time series, discrete sequences and chains, and spatial data, graphics and network data. For time series, it's generated by continuous measurements over time. For example, if we have temperature, heart rate, etc. And for discrete sequences and chains, it's similar to time series, but the values are categorical. For example, if you have biological data as amino acid chains, DNA, etc. Then for the spatial data, no special attributes, temperature, pressure, pixel colors, etc. are measured at special positions. Then for the last type, graphics and network data, we have values correspond to nodes, while relationships between the values correspond to the age. For example, if we have a social network, chemical components. Now let's see the main issues of data mining. First of all, determination of the most efficient algorithms for, first of all, extraction of new types of knowledge, management of uncertainty knows or incompleteness of data, advanced data types. Then for the interaction with the user, we have with flexible user interfaces, integration of basic knowledge, background, constraint, and rules. Then presentation and visualization of DM results. For the efficiency and scalability, we have the execution time of an algorithm must be predictable, short and acceptable by application, parallelism and management and distribution, then a DM and company, inappropriate disclosure or use of data, also potential violation of privacy and detection rights, data, observe data sensitivity and protect data privacy, people will performing a successful VM data mining. Now let's see the most important part in this video. It's about extraction of frequent patterns. Let's start with a basic concept. First of all, we have the item base. As you see, we have a B equal to this. This is a set of items. For example, you see this table. We have bread, butter, milk, eggs, yogurt, and cheese. This is an item set. An item is an element xi of B. But if we say item sets X, it's include in B. So key item set is an item set of key items. As you see here in this table, we have TID and items, two columns. The first column it represents the transaction, and the second it represents the items. Now we know what is an item base, item, and item sets. Now let's move to transaction. What is exactly a transaction? So if we say A is a transaction, so A is transaction on an item base B. It's a pair T, that's it's two thing, TID and G. For the TID is a unique transaction identifier, and for the G is include to be an item set. Now for the transaction base, a transaction base T, it's a set of transactions T1, T2, T3 to Tn. Is a set of transactions, as we already say. A transaction T, we have already said that T it's TID and G. It covers an item set I if E it's include in G. Now let's see the first and the most important algorithm in data mining for frequent pattern mining, the a priori algorithm. As you see here, we have begin and end, and in the middle we have the key, it's equal to 1. This line, it's for initialize the item set's size. Then we have CK, the second line, it's for start with one item. The third line, F key equal to run, it's to determine the frequent items. Then we have here a while. The condition here is that when F key it's different to 0, do begin. It means as long as there are frequent item sets, so do this. The first line, CK plus 1 equal to candidate FK. It's for create candidates with one element. The second line, F key plus 1 pruning, it's to determine frequent item sets. The last, it's just to increment the item counter. When the condition is not satisfied, it means when the FK it's equal to 0, so we move to return. It means we return the frequent item sets. Now we are going to see two most important properties in a priori algorithm. The first is monotonicity of the supports. The support of each subset G of I is at least equal to that of item set I. As you see here, so from the previous property we have the a priori property. No superset of no frequent item set can be common. As you see in the previous property, for all G include in E, we have the support of G, it's also greater or equal to support of I. Now let's see the association rules. Let X and Y be two item sets. The rule that X implied Y is called a rule of association with a minimum support as minimum and a minimum confidence C minimum if it meets the following two criteria. The first criteria is that the support of the rule X implied Y is at least as minimum. For the second criteria, the confidence of the rule X implied Y is at least C minimum. As you see, for the support of an association X implied Y, it's equal of the support of X union or join Y. The confidence, as you see, the confidence of an association X implied Y is just the support of X join Y divided by the support of X. All of this is just a properties, it's a lecture as you know. So in the next video we are going to see an example about the a priori algorithm with more details, so don't worry. Thank you so much for joining me today. I hope you found this video informative, and if you did, don't forget to hit that subscribe button so you never miss out on our future content. Your support means the world to us, and subscribing is the best way to stay up to date with all the latest video we have in store for you.